Welcome to True Projects. In this video, we are going to explain about a project titled Pancreatic Cancer Prediction Through an Artificial Neural Network. So now coming to the introduction part. Pancreatic cancer is a deadly disease that is often diagnosed in its late stages. This is because the pancreas is located deep in the abdomen, making it difficult to detect early on. Additionally, pancreatic cancer often does not cause any symptoms unless it has spread to other parts of the body. As a result, patients with pancreatic cancer often have limited treatment options and a poor prognosis. Early detection of pancreatic cancer is crucial for improving patient outcomes. This is because early diagnosis can lead to more effective treatment and a better chance of survival. ANNs are computational models inspired by the human brain's neural network structure. They are capable of processing vast amounts of data and identifying complex patterns. This makes them well suited for tasks such as image recognition and pattern detection. ANNs have used to analyze medical images such as CT scan, MRI to identify early signs of pancreatic cancer. They have also been used to analyze blood samples to identify biomarkers that are associated with pancreatic cancer. So now coming to the objective part for this project is to utilize an artificial neural network for the prediction of pancreatic cancer is to improve the early detection of this highly lethal disease. This means that the ANN will be used to identify people who are at risk of developing pancreatic cancer before they show any symptoms. This is important because pancreatic cancer is often diagnosed in its late stages when it is difficult to treat and the prognosis is poor. Pancreatic cancer is notorious for its late-stage diagnosis. This is because the pancreas is located deep in the abdomen, making it difficult to see with imaging techniques. Additionally, pancreatic cancer often does not cause any symptoms until it has spread to other parts of the body. As a result, many people with pancreatic cancer are not diagnosed until it is too late. The goal is to leverage the power of ANNs to develop a reliable predictive model that can identify potential cases of pancreatic cancer at an earlier, more treatable stage. This means that the ANN will be trained on a larger dataset of patients with and without pancreatic cancer. The ANN will then learn to identify the patterns that are associated with pancreatic cancer. This information can then be used to develop a predictive model that can be used to identify people who are at risk of developing pancreatic cancer. So now coming to the requirements part, here we have two types of requirements, hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have exploring the dataset, urinary-based pancreatic cancer dataset, and histopathology of pancreas cancer. This module involves an in-depth exploration of analysis of the dataset. It is designed to gain insights into the data structure and identifying relevant features for this project. Third, here we have data processing and cleaning for feature value and image data generated for images. Data processing and cleaning are essential steps in the data preparation phase of any data analysis or machine learning project. The goal of data processing and cleaning is to ensure that the data is in a format that can be used for analysis that is free of errors. Fourth, here we have visualization data using Seaborn. This model utilizes Seaborn libraries to create visualizations that aid in understanding data distributions and relationships between variables. And the fifth one, here we have feature selection and splitting the data. In this, we have to select the feature and split the data into train and test model. Next, here we have building the model. Building the model includes random forest model. It is an ensemble learning method that combines multiple decision trees to make predictions. Talking about the decision tree model, it is a non-parametric supervised learning algorithm which is utilized for both classification and regression tasks. Next, here we have naive-based. It is a supervised machine learning algorithm that is used for classification tasks. It is based on Bayes' theorem, which is a formula for calculating the probability of an event occurring given the probability of other events. Next, here we have SVM, that is support vector machine. It finds a hyperplane that separates data points into different classes, maximizing the margin between classes. Next model, named as voting classifier. This combines predictions from multiple algorithms and selects the majority vote as a final prediction. It proves the prediction accuracy by leveraging the strength of various models. So next, coming to the discriminant analysis, it is a statistical technique that is used to classify observations into two or more groups based on a set of predictor variables. It is a supervised learning algorithm, which means that it requires labeled data to train the model. Next, coming to the logistic regression, it is the supervised machine learning algorithm that is used for classification tasks. It is a linear model that predicts the probability of a binary outcome, such as whether an image is a cat or dog. Next model, here we have ANN, which stands for Artificial Neural Network. It is a machine learning algorithm that is inspired by the human brain. It is a non-linear model that can learn complex patterns from data. Next, coming to the MLP, which stands for Multi-Layer Perceptron, is a type of ANN that has multiple layers of neurons. The neurons in each layer are connected to the neurons in next layer. Now coming to the building the model for image-based classification, in this we have MobileNet. It is a convolutional neural network that is designed for mobile devices. It is a lightweight model that can be used to classify images on smartphones and other devices with limited computing power. Next, here we have Inception V3. It is a CNN that is designed for image classification. It is a more complex model than MobileNet, but it can achieve better accuracy. Now coming to the training the model, it involves feeding the model with a data set of images and their labels. The model will then learn to associate the features of the images with their labels. Now coming to the building the model voting classifier, because comparing to other models, voting classifier gives better accuracy. In this case, you choose a voting classifier algorithm because it has been shown to give better accuracy than other algorithms for image classification. Coming to the Flask framework with SQLite for sign-up and sign-in. Flask framework with SQLite for sign-up and sign-in is a popular Python framework that can be used to build web applications. It is easy to use and can be integrated with SQLite, a lightweight database that is ideal for small applications. Now coming to the user gives input. It refers to the user providing the image they want to classify. The image can be uploaded to the application or entered as a URL. Next, here we have the given input pre-processed and which trained model is used for predicting the performance. It refers to the process of pre-processing the image and then use the trained model to predict its label. The pre-processing steps may involve resizing the image, converting it to grayscale or removing noise. And the last one, here we have final outcome is displayed. It refers to the display of the predicted label for the image. The label can be displayed as a text or as an image. So here we have a folder which is named as dataset. In this we are containing some dataset over here which is used in this project. Another folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files, and the folder named as templates. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Now coming to the app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. Next, here we have a data set which is named as Debernardi, and the process are the two CSV files which are used in this project. Next, here we have signup.db. This file appears to be the database file which is used to store the information. So now just click over here and copy the paths, and now open the Anaconda prompt. Type cd command, give a space, and paste the path over here, and now just hit the enter button. And now type python app.py. And now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste this link and now hit the enter button. So here you can see that this is our home page. Now click on sign up button. Here you have to do the registration form by entering your username, email address, mobile number and password, and click on register button. Here I have already done the registration, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration, and now click on login button. So here you can see that we have to fill the following information over here. We have to fill patient's cohort. Here I am choosing cohort previously used samples. Sample origin, BPDB, entering the age. Suppose that I am entering 0. Or let's suppose that I am entering 20. Gender female. blood plasma 85, urinary biomarker of kidney function 2, urinary level of lymphatic vessel, here I am entering 22, for urinary levels of 14, 1, trefoil factor 1, 2, urinary level of 14 that may be associated with pancreas degeneration 21, choosing the diabetic patient, smoking, current, smoking frequency every day, alcohol consumption very low, race white, and now click on predict button. So here you can see the outcome. The patient is diagnosed as patient with non-cancerous pancreatic condition like chronic pancreatitis. So now let's try with giving some another examples. So here I am choosing second one, newly added samples, and let me now fill these details over here. So now here you can see that I have entered all the details over here, and now click on predict button. So here you can see that the outcome is the patient is diagnosed as patients with non-cancerous pancreatic condition like chronic pancreatitis. So now again let's try with another example. Let me enter the details again over here. So now here you can see that I have entered all the details over here, and now just simply click on predict button. So here you can see again the patient is diagnosed as patients with non-cancerous pancreatic condition like chronic pancreatitis. So now just click on image button. Here you can see it is asking for choosing a file. So now here you can see that here I am choosing this image, and now click on open button and simply click on upload button. So here you can see that the prediction for the uploaded image is detected as pancreatic cancer over here. So now by clicking on the try again button, let's try by uploading another image. Click on choose file. Here I am uploading this image, and now click on open button and now click on upload button. So here you can see the prediction for the uploaded image is detected again as pancreatic cancer. And now let's try with another example. By uploading with another image, click on choose file. Here I am choosing suppose this image, and now click on open button and now click on upload button. So here you can see again it is showing that detected as pancreatic cancer. So depending on the image you are providing over here, it will detect about the pancreatic cancer or not. By clicking on the about button, here you can see, so here you can see that there are many different graphs depending on the accuracy and the models we are using over here. It is showing which algorithm is giving better accuracy. And now by clicking on the sign out button, you can successfully log out with this. So now coming back to the conclusion part. Pancreatic cancer is a deadly disease that is often diagnosed in its late stages when it is difficult to treat. This is because the pancreas is located deep in the abdomen, making it difficult to see with imaging techniques. Additionally, pancreatic cancer often does not cause any symptoms unless it has spread to other parts of the body. The late-stage diagnosis of pancreatic cancer has long been a major obstacle to effective treatment, leading to high mortality rates. This is because pancreatic cancer is a very aggressive disease and is difficult to control once it has spread. As a result, the 5-year survival rate for pancreatic cancer is only about 10%. However, the application of artificial neural networks in predicting pancreatic cancer represents a significant step forward in the fight against this disease. ANNs are machine learning models that are inspired by the human brain. They can learn to identify patterns in data, and they have been shown to be effective in predicting pancreatic cancer from medical images and other data. The proposed model of voting classifier and random forest, and for image inception and mobile net as extension, in which voting classifier gives better accuracy, around 96% of accuracy, and mobile net 99.92% accuracy. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.